So we're seeing a lot of adoption in this space, and it's only going forward. I think Google and other companies are coming up with newer techniques every year. Recently came up with a new language model called Lambda, and we're going to see more and more advanced developments in this field, which will help things like speech detection, intent classification, and stuff like that.
We can't hear you, Sujikar.
Sujikar, we can't hear you.
I think you're probably on mute.
Sorry. Yeah. So, Soundgar and Ashwin, I think that was a vast overview of the use cases we have at the moment, and maybe the journey in the AI took over a period of time. Now, I think a little bit understanding of when you said, even with the customer-facing solutions and also the back-end operations of it, business decisions, the AI is getting involved. Now, in these scenarios, looking at the architecture, maybe product from a product viewpoint, AI architecture, how do you see the development in that? Maybe from there on, we can move on to the skill sets which are needed by students who are going to come into the professional world moving forward. So for that, I think we can create a base for the AI architecture, being what is a mature architecture and non-mature, and the flow it can have in the future.
Yes, great question. I think this is a very interesting question, because these are the kind of questions, Sujikar, day in and day out, I and Ashwin are constantly engaging customers with. We have seen so many different kinds of architectures. So I'll try to, I think the answer for this, I'm going to first talk about, when we say an AI architecture, what do we really mean? And then I'll open up the discussion some more where, Ashwin, we can talk about what is the maturity, and from I think, Ashwin, maybe you can focus on the answer more on the cloud. How are cloud supporting this, and what kind of different solution components? And because Ashwin comes from a real solution background, and he'll be a very good person to answer how it's evolving from a solution angle. I'll try to give you a little bit more data science angle to this, and then I'll let Ashwin deal with the solution side. So when typically organizations say architecture, let's start with, I would call it more of a business architecture to start with. So if you see the business architecture, typically in the, let's say 10, 15 years back, during the times of business intelligence and analytics days, the systems were a lot more siloed than they are today. So they used to kind of work in isolation. Different departments, it's almost like, imagine like one big company like General Electric, GM, or any of these big companies. But in reality, if you see inside the company, there are bunch of like small, every department is like, they're running like, it's like a small company in itself. There's so many people, and they do their own thing. And they have their own systems, they have everything in place, and often the systems don't talk to each other. In fact, even people don't talk to each other sometimes. So there are a lot of those kind of issues that initially they started out with. So the business architecture initially was very fragmented to start with. This entire analytics was very fragmented. We started seeing some kind of consolidation with BI, where organizations realized the need that instead of every department trying to manage their own data, manage their own business process with very little, let me put this, collaboration, true collaboration, if you will. And that was lacking, of course, to start with. So it was a very kind of individual, every department would have their own statisticians, they would have their own data engineers, and they would do their own thing. And it was not really a cohesive effort. Now, that started evolving. Once BI, they started realizing that, okay, let's start building warehouses where we get all of this data together. At least we have all of the data from different departments in one place, one database, or one single point where people can access it. And then let's start so that everybody can build their analytics on top of that. And that kind of architecture started evolving. Now, having said that, that sort of architecture is largely what you see today in different form, really. See, it started out with a warehouse, and then a warehouse became, and they're more fancy words they came up with called data lake. And then data lake became, data lake on the cloud. So there are different kinds of, terminology that evolved, but all of them essentially mean the same thing, right? You have centralized data to a certain location, and then there's bunch of analytics or analysis that is being done on this database. And this database, typically, if you consider a company, it had data from their billing department, it had data from their finance department, it had data from their front office systems, like for example, sales and service portals. It had data from, if there was a complex supply chain, there was data from all of the complex supply chain. And all these big companies invested millions of dollars in huge programs, $1 million programs, which literally took months and years to build, where even after centralizing all the data, they still struggle to make sense of it and create one kind of a standardized structure where everybody could understand and be able to relate. I mean, that became a problem, and people invested millions of dollars in doing that. And so the idea was, okay, initially it was all fragmented. Then they said, hey, let's centralize all of this. So got all of these different data together. But then the next problem is, there's no single person who understands all of the data. So then there were these huge programs, people working together to figure out, make sense of this data, to standardize it so different departments could actually use it. So that was the next step in the evolution. And in the next step, their intent was, let's get all of this data together, understand it, standardize it, so all of the data scientists and all the analysts can come now and start building their machine learning models or analytics on top of that and that sort of thing. So that started taking off. See, now we're at an interesting stage where many companies have at different levels of maturity. Of course, some of the bigger players, the market leaders, have got their act together. So they have built these giant data lakes, and they have all of these different machine learning models that are working. But I think this is just the starting point. I think if I were to really truly forecast where does this lead to, I think it lead to, if you look at what I called an AI-enabled enterprise, then at the point, the analysis of where the data is done, today it's primarily central. I think eventually you will come to a hybrid where people are also realizing now today that centralization is not necessarily the best idea for all situations. So there are situations where you may have to decentralize your data. You may still keep it in silos, but can you have systems in place to be able to still make sense of it and avoid these efforts where you're spending months and months trying to get this data together ready for analysis. So I think you're going to start seeing hybrid systems in the future where your analysis will get more real time, and all of these machine learning AI models will get closer and closer to where the source itself is. So as the data gets generated, in fact, think of it this way, right? Instead of now in the previous paradigm, you were getting the data to where the algorithm was running. See, these algorithms were all running somewhere, possibly in the cloud or possibly on-prem or wherever they're running. But there is an anti-pattern which is also emerging now, where you're saying, instead of centralizing the data, getting the data closer to the algorithm, how about you take the algorithm and get it much closer to the data? Will that solve the problem? In some situations, I think people are finding success, and that pattern is going to grow. And we'll see more of this. But eventually, I think my personal view is it will settle to some kind of a hybrid situation. And again, as the traditional wisdom goes, there's no one size fits all here. People will come up with different solutions. And with that, I think that's a good segue into the solution aspects of it. So Ashwin, I will probably ask you to comment on the solution aspects of this.
Yes, I think that's very, very interesting. I think I'll answer the solution aspect in a slightly different way. So let's talk in terms of the kind of personas or the skills that were used previously and what has changed now fundamentally, right? So if you see earlier, when data science and AI used to be done in silos, you pretty much had a data science team, which were primarily these data scientists. And they used to do everything. They used to acquire data, they used to prepare data, they used to build models. And in many cases, they even actually deployed those models. These models would be deployed not really in a production scenario, but as an offline setup. Right? But what has changed right now is that the whole pipeline of AI processing has become multidimensional. So it has actually broken down into multiple stages. So you have stages, and the reference from this came through a framework called CRISP DM, CRISP data mining framework. So it identified certain stages, but that has actually been enhanced and adopted in the industry. So some of the phases that we are seeing right now are you have specialized processing unit for data ingestion, data analysis, data transformation, validation, training a model, building a model, inference, model validation. And then we have final phases, which are more to do with serving the model, which is hosting the model in the production setup, and monitoring and logging of that model. So these are some of the more refined steps that have come up. And
sorry, Ashwin. I think this is the right time, as you mentioned, the different steps in this data science flow. Maybe if we can even discuss a bit about the possibilities for students to start with.
Yes. I was actually coming to that.
In the form of roles.
Yes. So this actually opens up a lot of opportunities for people who want to get into this field. And the good thing is you don't necessarily have to have a master's in data science or computer science for that, right? Because the data science team today rather is actually a multi-skilled team, and which brings in skills from multiple areas. And this is true for all major tech companies and enterprises today. There's a concept called the data science team now, which has skills such as data engineers, which are essentially people who prepare data, right? They acquire data, they transform the data, they make it ready for analytical use cases. So those skills typically are skills around big data, data preparation, Python scripting. So these are skills which are very much needed. So people who are embarking on this journey have an entry point from this side as well. So if you are getting started in big data, for example, so you have a very good entry point into AI if you kind of just build up on the skills. So things like Spark based systems, Databricks is a big company that's promoting Spark kind of technology. So Spark is mainstream. Then learning some of the data processing tooling around that streaming kind of data. So Kafka and these kind of streaming technologies, these are very, very important if you're trying to get into that field. And Python actually has become mainstream. So I would strongly suggest learning Python at this stage. Java-based tooling around data processing is on the decline. I would say I would rather urge the students to concentrate around Python-based tooling, and then the DevOps, right? So essentially, DevOps has now become what is called MLOps. So this kind of skill set actually is around bootstrapping a lot of infrastructure for AI, and then cloud has actually enabled a lot of this. So each of these clouds, if you talk about Google, if you talk about AWS, you talk about Microsoft Azure, each of them have their own specialized services, which requires certain element of skills around building out these infrastructures on those clouds. So, and then there's a certain automation in the process, which is called MLOps. So how do you automatically acquire data? How do you automatically launch certain jobs? How do you kickstart a job for training the model? How do you package the model? How do you automatically deploy? So these are very intricate steps, and this requires a lot of cloud-based skills. So DevOps is another aspect where teams can have an entry point into this field. And one of the key technology in this field is container technology. So right, if you heard of things like Docker, right, and Kubernetes, so these are going mainstream. So all of these companies heavily leverage this. So this is another entry point for students who want to get into this space, are building on, are probably have skills in some specific area. So you can actually have an entry point into this as a part of that team, right? And then, of course, the data science scientist role particularly, right? This could be a specialized field. You have to probably have a master's in similar field, computational heavy field. Some of these companies do very intense and hardcore research-oriented data science. In such cases, a PhD is typically preferred. In these cases, you're actually developing entirely new models which are not there, probably talking about different algorithms. But not everyone has to go through that cycle. There's another very interesting role that has come up, and which is called an ML engineer. So this role was not there before, right? In the last few years, we are seeing this role of ML engineer coming through. So what does this mean? So another way to think of it is this is essentially a citizen data scientist role, which means these are essentially engineers who have software development skills, but know enough about data science, right? So you might have to know the fundamentals around the mathematics of data science, right? talking about the concepts around calculus, probability, statistics, but just enough. You don't have to really major in that field. But then quickly applying that into how do you use some of these models, these algorithms that are provided by some of these tools. There are a lot of tools in the market right now which are mainstream. TensorFlow, PyTorch, Scikit-learn, all of these come with their inbuilt algorithms, and then the actual training process has become very much simplified. So these are engineers who actually use these tools. They are more, adept at leveraging these tools. They are not really about researching a whole new technique of building a new model. They are more about iterating over those, parameters, hyperparameters, and then they are repeatedly trying what is the better model to arrive at. So this is a kind of a role that has come up, and people who want to stay close to the heart of data science, this is probably a good entry point. So I would say this is one area to target. You would probably typically start off as a junior trainee in assisting one of the senior data scientists, but very quickly you will actually start leveraging some of these techniques and tools, and that ML engineer role will be very well suited for you. You might have to double down on your skills around big data and DevOps a little bit, because you might have to have skills around both of them. But this is a good area for you to get into. And then continue on the MLOps, the DevOps, there's a production side of things, right? Where these AI models are not deployed, right? And then they're serving live products. So if you are buying a product, you're doing a transaction, everything is hitting those AI systems. And somebody has to monitor them and then figure out. So one of the, I would say, the risks and one of the challenges in AI models is models get stale very fast. Data in the real world changes. So some of the models that you built in the past no longer are relevant. So you constantly have to keep them updated. How do you constantly monitor them so that your customers have a seamless experience? So you automatically bring in new models trained on the new data. So these are some of the skills that are needed to monitor on the production side, kickstart a whole new retraining process. So again, a lot of DevOps kind of skills are needed in that space. So as you can see, multifaceted. And then of course there is people who are coming from business side. There is a product management aspect to it. So how do you, when you're launching a product centered around AI, you have to do a lot of business planning. You build things what we call minimum viable product, right? And what is the right candidate for you to go to the market and then define which can potentially generate revenue. It's you have to have a balance between what you want to aspire to versus what you can consume in smaller segments. So that is kind of a product management, product planning needed. It is a cross-functional role. It talks to a lot of engineers, technical folks, business users of the system. So that's people. I see some students who are from MBA kind of background. Probably this is a kind of a role that would suit you, where you are driving discussions, talking to a lot of technical folks, business folks, charting out a plan, how to use AI systems. So multiple areas for people to get into AI right now. It's not necessarily you need to have a master's in computer science or mathematics for that.
And to add to Ashwin, I will add a couple of new roles that I have seen, which are emerging, which is still kind of not recognized formally as a role, but in the future, I expect it to become more mainstream. See, Ashwin talked about one aspect of, the challenges with machine learning models, where models degrade pretty quickly after production, and you need to constantly keep them updated. So I think we are talking to, I'll give you a practical example. We are talking to a pharmaceutical company, I and Ashwin, where their problem statement is around how do you validate? How do you know that there's a certain model is good enough for production? And how do I know when it is going stale? And how do I ensure that I minimize the errors that an AI model makes? See, remember, AI model at the end of the day is no model will be 100% accurate. There is only a certain level of accuracy based on a specific evaluation metrics that you might have chosen, whether it's precision, recall, F1 score, whatever be your evaluation metric, it can only be precise to a certain extent and threshold. So there is this entire validation process of machine learning. I think that role in the future, I think it will get more and more formalized. Think of it, that analogy is a QA in software, traditional software development, where you do QA on your systems before you hit production. So now I think that role in the future, today it's being loosely done by data scientists and ML engineers, where they test the quality of their models and to see how robust these models are. before they hit the production. But I think you will see an emergence of this new role where think of like a QA engineer is to traditional software development. I think you will increasingly start seeing AI validation experts who, which will kind of get, I think it will get bifurcated. What was being done by a data scientist will slowly start being done by these validation experts. I think that role you'll see emergence. And another area, which is very interesting area, which is based on another customer in the high-tech domain, where Ashwin and again myself have been working with this customer for the last 1 year. And the sort of problems that we are seeing there is user experience. I mean, interestingly, you know that in building user interfaces for any of these applications that are commercial, there is a big angle of a user experience behind it. So how do you design a user interface for a product to be friendly, and this entire UX, or what they call the UX process? Now, for an AI too, I think it will become increasingly more important, because remember, all of these models that are typically scoring something, like, I mean, if you're applying the AI to your customer data, you're scoring every customer for certain probabilities, whether a customer will buy a product or customer will, let's say, if you run a certain promotion, will he accept it? Or like the example that Ashwin is talking about, will a customer churn out or not? All of these different metrics that you see in the connection, in related to this, I think all of these will go towards some kind of a user experience where, how do you use all of these insights? So you have all these scores, that's great. Now, what does it mean? What does it mean, say, suppose there is a score on a certain customer which says there is a 80% probability of churn. Now, for somebody in the business teams to really understand what is this, interpret what this 80% is, it's not actually obvious. It's not, a lot of these cases, it's just not obvious how to use these scores. Now, how do these scores get presented? When should these scores be used? In the context of what business process are these scores used? So the entire experience of, for example, if these scores are being used by call center agent, now there's an entire experience behind. See, remember, when you call a call center and an agent actually takes your call, there is a standard operating process that the call center agent follows. What should you do when he's talking to you? What sort of standard operating procedure should you apply? What is that, a complaint? Is that a service request? How do you actually apply that? There's a proper structured process behind it. Now, I think AI too, once it starts getting integrated to all of these different processes, there will be user experience aspects of how you use AI. So entire usage of AI, how does a business actually consume AI for its growth? And the user experience behind it is another huge emerging area. And this again, I think it requires a great confluence of skills, business skills, testing skills, so which are not kind of mainstream, as I would say, like a data scientist. You don't need to be working with algorithms for all these different areas.
Yes, case in point is like designing virtual assistants, right? So the way you would design like a voice-only assistant, like Alexa or something, and the conversation around it would be slightly different from how you would design, let's say, a chatbot where you're typing something, right? Where you have much more information. So there's a slight differences, nuances. So this is like a user experience design. And then how do you make, your customer experience delightful? So how do you give information that is seamless and they can consume information in real time and they don't have to actually go through a whole lot of cycles to find out what is needed? So there's a design elements needed, but you need to know enough about AI, what AI systems can do for you. And then companies like Netflix and all, and Amazon, it's like there's so much AI around. If you just go to the screen, everything is centered around AI, but you never get to know that, right? And that's the design element of it. One interesting emerging field that is also coming through, which in a few years I'm sure will be very important, is the area of ethics, right? So this is people from humanities background, I think, if somebody is there or has an interest in that. Because what happens is a lot of these AI systems, because they are trained on corpus of data and they are trained to find patterns in the data, they develop something called bias, right? Bias could be just because they are seeing only a certain part of data and not seeing the other part of data, which is not available to them. So whenever a situation comes forward where they have not been trained on that kind of corpus of data, or for whatever reasons, demonstrate a behavior which is called bias, right? And a quick example of that is certain demographics get left out in loan processing, for example. If you are from a certain demography, from a lower income background, if you apply for a loan, and even though you meet all your qualifications, the AI system, because it's trained on certain data which has been trained on certain demography, it has an influencing factor, and it may even reject your loan. And that applies across the board for different use cases. So as an enterprise, you don't want to do that. You don't want to end up in a legal position, and both from a moral standpoint, right? You don't want to put out a system that is discriminating against your customers. So that AI fairness and bias, so these are fields that are emerging where you need kind of specialized tooling to actually detect, is your system biased, and then actually report that, to the authorities and to the leadership that, probably your model, even though it meets certain level of accuracy. So accuracy and, bias are two separate concepts. They don't necessarily go hand in hand. So you may have a very accurate model, but you may have a lot of bias in it. So that's something which these kind of new fields will actually highlight. And this is on the horizon. This will become very, very important as AI goes mainstream. Sujikar, if you're trying to say something. Sorry, you're on mute, Sujikar.
Yeah, sorry on that. Trying to summarize, I think the roles which you have discussed here. I think even there's a flow there coming to the data, and then data management, that is your data engineers and all these people would come up, and then we were talking about the production side, and then product management part of it, and also the futuristic AI needs, be it validation experts or user experience cases to be dealt with, and even to deal with biases. So I think we do have a very good overview there in terms of the roles which are available for people to come and go there. I think you even touched upon the R&D aspect of it, the PhD factor coming in when it's about research. So just to top it up, I think
there's a lot of interesting. There's a lot of questions that I find in the chat.
Yes, exactly. So we have that is the reason why I was coming to this summarization aspect of it. I think we do have around 20 to 25 questions, and few more will flow in. Maybe I'll just ask a final question from my end, and then after that is answered, we'll take a couple of minutes break. And after, during then I can look into the questions and then select few of them so that you can answer. Maybe later, I can send across the question to you if you can please provide your
we'll take as many
answers for.
Sure. I'm glad there are questions.
Yeah, there are many questions to go in. Just the final summarization question, wherein how is India standing here? So for students in India, should they look outside to become to make their careers in data science and associated careers, or is India also providing suitable opportunities, both in terms of R&D as well? I think in closing remarks from both of you, then we'll move on to questions.
I can certainly take that question. Ashwin, do you want to take that, or do you want me to answer that?
I can certainly take that. So yes, I think students in India, I would tell you that you are in a very enviable position. One thing that at least the Western countries, the US in particular, is struggling is getting more and more data scientists, right? But there is only a certain number of that skilled resources you can have, and especially this is a new field, so you don't have necessarily a whole lot of experienced people in that field. So the demand is far exceeding the supply right now here, and as a part of that strategy, they are typically looking at offshoring and going out to their own offshore centers. So at least what we are seeing, and we are hopeful, is a lot of opportunities will be created in this field within India. And we have already seen a lot of companies around Bangalore, Hyderabad, Mumbai, Chennai. They have a lot of companies which are adopting data science based work. So there will be a lot of opportunities. Absolutely, you don't necessarily need to look outside India. But having said that, yes, in terms of demand, US is leading the way. There is absolutely a lot of buzz around AI. Everybody wants to incorporate AI in some form or the other. So that's driving some of the demand.
Yeah. So let me just add to that, Ashwin, and then maybe Sujikar, we can go to the questions side of it. So I think as I was glancing through the question, I saw an interesting question on this. Somebody asked about this post-COVID world and AI-driven. Very interesting question. I thought I'll combine with this because that question is kind of connected to what you asked, Sujikar. See, the post-COVID world, right? I don't know whether we fundamentally realize that COVID has fundamentally shifted things in the world. So there is going to be a new normal. It's not going to be the old normal that you thought of before. And for AI, it's a great thing because one of the in the post-COVID world, which has only accelerated the pace of digital adoption, or everything going digital, everything going online, and things getting more digital. I think the AI is going to even accelerate on account of this post-COVID world. Now, traditionally, let's look at India, right? Of course, having said that, what Ashwin said is true. There is a gap in terms of where are we as a country in terms of applying AI to a lot of our own problems, right? See, remember, the sort of problem that the West is trying to solve, typically MNCs in the West, it's all around big companies trying to solve using AI for improving the profitability, margins, better customer experience, very, very kind of this sort of problem. But imagine, India, the nature of problems are very different. The kind of companies that are coming out with solutions also very different. So I think in the post-COVID world, in India, as some of these companies accelerate and create these new age digital platforms, now you're already starting seeing, for example, there is a company called Koo, which is a competitor to Twitter. Now, Twitter, typically companies, these big social media companies like Twitter, Facebook, and all of these companies, one thing they did right is they collected a lot of data about you around the world. So one of the reasons also why some of US, China are ahead of the game is they have a lot more rich data about the consumers than compared to India. We didn't have that scale of digital platforms yet. We are beginning to see them now. So it will only accelerate because of the post-COVID world. So I think to add to that answer, net, the summary is, I think the opportunity that you'll see in India is tremendous. And what is really exciting for me is, I don't think in India, they will probably necessarily try to follow the same Western model in terms of trying to solve problems pretty much the same way. You will see unique problems in the Indian context emerge. And I think you will see new kind of AI thinking emerge, which will actually not only kind of get us to a point on parity with US and China, but also start developing really unique assets or IP in terms of AI, because the problems are also different, right? It's different. It's not the same like in the Western world.
Yeah, and I'm talking in terms of maturity, right? I think you talk about pure, Indian companies, service play companies. All of them have a major initiative around AI, right? I mean, if you go to any of those TCSs, Infosys of the world, everybody is talking about AI. So they are actually building a lot of teams and capabilities. And then you have these niche product startup companies in India. I mean, Sujikar, your company is an example. You use AI inherently, right? So that's a very good example. So a lot of tech companies use AI in a very interesting fashion. And the thing with AI is it's an open wide world. It's a wide canvas. You can use these techniques to solve your own business problems. As Suman rightly said, Indian problems are different. Indian companies the business model will be slightly different. So more and more opportunities will be created to solve some of those problems.
Yeah, I think I have a laughing face here at the end of it because, people like you, Ashwin and Suman Kalyan garu, you being in North America and then talking about unique business, unique cases of AI usage in India and positive side of it, okay, in the coming days, I think I am feeling very good at heart. I think brain power here itself and then make solutions out of it. Okay, and explore the scenarios moving forward. On this note, thank you Suman Kalyan garu and Ashwin for this great discussion which we had. Now I think if we can take a couple of minutes break, and I will go through the questions which we have and I'll pick as many questions as possible and maybe we'll spend some time pondering over them.
Yes.
Sounds good.
Yeah, meanwhile, handovering it to a couple of minutes.
Yeah. Hi everyone, thanks for sticking around, and we have noted all the questions which are present. If you're not able to answer some, we'll send you an email across with the answers, however best we can answer, and we can get in touch with both the speakers for the same. I would just like to take a moment and talk about CI internships. A lot of people I've seen like at least 3 questions about the same. So basically CEI has works with students, and it is focusing on upskilling the students. So definitely I will be sharing the details of the admission procedure for the workshops. The organization is in network with a lot of industry stalwarts who are helping students one-on-one, and who are giving exposure to the students with regards to different strategies, research, and all these different domains, which definitely provides a holistic exposure to students and prepares them to become a part of a more holistic and empowered world. So definitely on via email I will be sharing more details about the internship and the admission form itself. I will also drop it in the chat in a while, right? Another thing I wanted to talk about is our platform itself. So definitely our platform, as all the 3 speakers spoke, we are focusing on helping students become more employable through our technology, and helping them identify their own skills and their own gaps, so as to improve holistically and be able to identify their gaps. So just to give you an example, I'll just take a minute to give you a brief. This is a platform, this is a technology called the Employability Positioning System. There are different domains in the tech field itself. You can take the assessment, you can participate with the AI. The AI will find a position for you on the map on the basis of various data points, as has been the discussion point today. And it will tell you which domains are you suitable for, which careers you can pursue, and it will also give you free resources to learn and upskill on. So there are videos, there is curated content, there's a lot of information which is available directly on the platform itself, and all of it is free for students. So definitely learning domains, just to give you an example, so if I go for web development, definitely going to finding a roadmap here, and then finding videos which are recommended to you on the basis of the assessment that you've given, on the basis of your skill. You can actually directly learn for free through the videos provided here. So you can check out our website. Shivai ji has submitted the link also. So you can check out the website, and definitely you can apply for CI internships. You will get a response soon. Okay, I think over to the speakers back for the questions.
Yeah, thank you, Tanvi. I tried to put across some questions. The first among them, let's start maybe from the fresher viewpoint, where Sumukh Shankar is asking a question about, as a fresher, is it necessary to know the deep mathematics involved in AI algorithms? I think the importance of mathematics in data science, I think you can maybe answer the question from that viewpoint. Suman Garwal.
Sure. I can take that question. So who asked that question, Sujikal?
Sumukh Shankar.
Okay. So here is what it is. So I think Ashwin was talking to you about these different roles. So based on what kind of role that you want to go for, is that an R&D data scientist, or is that a data scientist which for a specific domain where you may have to invent, let me not say invent, right? At least use existing algorithms, tweak them to make it work much better. If you are working in those sort of areas, then I think having a good mathematical foundation and a background will certainly help. And but if you are taking more of an, let's say, for example, positions like ML engineers, ML ops, maybe AI validation, possibly you may not need so much of a mathematical background. So I think it all depends on what kind of role that you want to get into when you get an entry into the domain, and that will. But however, having said that, I think it's good for everybody getting into data science to have some basic level of math for sure. I would recommend things like at least knowing basic calculus, being able to work with linear algebra. These are a couple of those things I would definitely recommend as a foundation. But again, depending on the role, I would say you should look at the level of mathematical abilities. Do you want to add anything to this, Ashwin?
No, I think that's exactly right. And then some of this, people who are, let's say, from an engineering background, some of this you already learn as part of your course curriculum. Right? You just essentially have to extend. The concept of calculus are pretty much the same. Linear algebra is the same. So it's not much of a steep jump. So you actually have to correlate what you're learning and maybe add on some of the gaps. But nonetheless, it's always important to have a solid, rigorous mathematical background. It helps you further down in your career. Right? You can certainly learn tools and learn how to operate them, and then catch this up later. But whatever be the case, you certainly still would need certain amount of basic math skills around this. So yes, there's no easy way of getting through this except learning this. In some cases, yes, I mean, depending on your role, where you absolutely don't need to do the mathematics, like in ML ops, right? You just need to know some of these cloud native concepts and stuff like that. So that probably would spare you that. But as a thumb rule, as Suman rightly said, yeah, it's always better to have some background in mathematics.
Yeah, I think even my own experience. When I was in college, I still remember all the statistics and even linear algebra, calculus, different even vectors, matrices, being taught to us, and I still remember those. So now when I'm getting to data science, I'm having a look at it, I still remember. So I think students, if you're in first and second year, please make sure if you're serious about data science, I think being in the college and getting learned in the classroom about these might be the right way to go for you, because it is being taught in the engineering, I think, courses.
Yes, absolutely.
In India at least.
And the good news is, Sujika, the good news is for most of these roles, unless you are, a role requires you to be a PhD in data science, where your mathematical skills needs to be much higher than, higher than normal. But most of these roles, university level math is good enough.
Yes. Now moving on, I think me being a mechanical engineering, I am a bit biased here. Philip Kumar Verma has this question where he's saying, what will be the future scope of AI in mechanical engineering field? So if a graduate of mechanical engineering wishes to get into use AI, then what is necessary, expected skills and approach for him? Maybe we can consider the engineering as such.
I can take that.
And maybe you can answer.
Yeah, go ahead, Ashwin.
I think that's a very very exciting field to get into, right? So when I say mechanical engineering, things around robotics, right, and self-driving cars, these are all AI systems, but heavily backed by mechanical engineering kind of concepts, right? So a lot of these industrial companies are leveraging AI right now to do few things. A, make the products better, do things like higher uptime, availability. We work with some industrial majors where they have things like wind turbines, gas turbines, which actually are powering plants. And then any downtime for that is very, very expensive, right? I mean, you cannot have a downtime for some of those manufacturing units or energy generating units. So you need to collect data in real time from such systems, and then create a predictive model which can say, hey, the system is going to fail in the X number of days. Why don't you replace this part? So a lot of predictive analytics are being built into it, and many times these are actually deep learning models which are powering that. Typically, there's a mix. What I'm seeing between physical models, simulation models like finite element models, which are pure engineering models, which detect failure, and then you are also complementing these with AI-based models, which are actually mathematical models built out of the data that the system is creating. So that is actually the term for that is called a digital twin. So you're actually creating a replica of the system using some of the data points. So you need to have an understanding in mechanical or some of this, adjoining engineering fields to be able to tell what that data means actually in the real world. So it's actually a combination of domain skills in your engineering side as well as deep learning side. So yes, a lot of heavy industrial major companies are actually leveraging AI mainstream. It's being used in manufacturing, transportation, and interestingly, coming to transportation, I think Suman and team, they're working on one of the new very interesting use cases where for a major North American, train company, like a metro trains you have in India, they want to predict the right accurate time at which it will arrive at a certain station. So, they are collecting data from multiple sensors and telemetry, and then they are able to predict, okay, this train is exactly going to arrive at this point in this at this station. So yes, I mean, even if you have a degree in which is not major in computer science, you can still actually get into this field because other fields are also leveraging some of these techniques. It's a very interesting place to be in.
Yeah, I think that was very aptly answered, Ashwin Garu. Now, the next question, I'm trying to choose questions across various scopes here, so that maybe 2-3 questions are answered together. Here, there is question from Vedika and Suraj about MNCs choose the training of data and grow procuring it. So, in that scenario, what about the ethical standpoint there? And if there is efficacy, check the efficacy of the training algorithms in that way on the ethical standpoint. And following up on that, Suraj is asking us about the large customer database which is being used to analyze through AI. What are the measures that companies are taking to protect the customer-based data?
I think Ashwin,
and other security risks.
I think Ashwin, you can take this question as well.
Yes. So consumer privacy has been kind of a thorny issue when it comes to some of these companies. I mean, a lot of these major tech companies have been criticized exactly for that, right? For example, at a high level, they say, we have actually anonymized your data. I mean, your data stays with us. But then we have these cases of Cambridge Analytics, like Facebook, right? So even though you'd be surprised and alarmed to know that even though you can anonymize certain part of data, it's as easy to de-anonymize that, right? So in theory, while you can tell your consumers that they have anonymized data, I can de-anonymize. But what is happening? We are seeing a lot of regulatory standards being incorporated, especially in the European Union, and slowly it's also actually starting in the US, and I'm sure pretty much eventually India will catch up too, is that government authorities are enforcing that you have to maintain certain amount of privacy of data, right? So that's getting more and more enforced. Now what will happen as a part of that is that some newer techniques will start to come up, and we are seeing companies experimenting with that. Some of them are actually using mainstream. So there's a concept called federated learning, right? Which Suman briefly touched upon. So federated learning is a concept that you don't take your data out from the consumer side and then bring into your own system. You actually take your algorithm to the data. So if you have a mobile phone today, right? Many of you may not know, it actually has ML models running behind the scene that are constantly getting trained on your data, and that's all locally. So your data is not leaving your space, right? It's not actually landing up to the cloud provider or the software consumer company. But what happens is when the model gets trained on your data, your usage patterns, it actually sends some parameters back to the centralized server. Now, the way they have classified this parameters is not data, so you're actually sending the parameter back to the centralized server. And there's a master model that actually gets trained from all of these parameters that are coming from different devices, and that gets trained. So that's one way to circumvent privacy issues. So when the master model gets trained back, it gets updated, so that pushes back a more updated model back to your mobile device or something like that. So those are kind of things happening that will become mainstream.
I think. Yeah, maybe regulation by government authorities, and at the same time maybe taking the ML models to the devices themselves and locally performing those operations.
Yeah, I think just to add something interesting to this privacy thing, I was Ashwin, I don't know whether you remember, I was reading about this thing where although the data was anonymized, but based on a few parameters, somebody did an experiment and was able to uniquely identify. I think I remember reading about that in the media some time back. I think my guess is this, Ashwin, this entire concept of differential privacy that people start talking about, is it connected to this?
Yes. Differential privacy is something very, very kind of well connected to that, especially it's being experimented in the healthcare field. So healthcare is very sensitive to your personal and private data. So differential privacy is actually, let me put it this way. So once you have certain personalized data around you, what differential privacy does is deliberately adds a lot of noise to the data. It's very difficult for other system to actually decipher because of the noise that has been injected into the system. but it has enough so as not to cause model skewness because of that noise. So it's it's a emerging field. It's still we need to see how that evolves.
No, in fact, Sujit, in relation to this, India has some interesting developments in this. I don't know whether people are aware of this. I think, if I remember correctly, this was, I think, a media article I read maybe a few months back, where I think it was ISC or some another organization like this in India, where they came up with this quantum encryption. They actually successfully be able to use quantum keys for encrypting data so that it cannot be hacked. Only the person who has the encryption key or using what they call the quantum encryption, right? Which is almost near impossible to crack or intercept, or for these hackers to get into it. And they actually had a demo of this somewhere in India where they are able to transmit data using quantum encryption. I think that's only going to grow in the future.
Yeah, so I think that's a whole new segment, quantum computing, that opens a whole new field altogether. Yeah, I think as an analogy to that, somebody actually decrypted an RSA key in 7 seconds using a quantum computer. So just imagine the power.
So I think interesting developments on that also. I think now the ethical part of it, privacy part of it, will be taken care of maybe in the days to come. These are all initial hiccups maybe for any new technology.
Yes, a lot of developments in this field.
So now I think we have another 5-10 minutes with us. So maybe we'll try to answer 2 more questions, and the other questions which are a little bit technical in nature about F regression and all. Maybe I will try to forward them to you. If you can find some time and reply back, that will be very helpful for the team. The 2 questions out of these 2, the first question is about the students who are in MBA. Sharwani Sarvi is asking this question. My question is about how can non-technical individuals like MBA, marketing and operation professionals can get into AI, as AI would be great help for them. The second question from the same person is, AI is replacing individuals. How can we not be affected negatively, and what steps should we take to always be benefiting from AI without being replaced? I think they're talking about jobs being replaced by technology.
Yeah, no, it's a great question. See, one thing is, you're right. You rightly pointed out, one thing is AI is also leading to a lot of automation as well. It's true. It's a fact of life. Like you had the generation where the first wave of digitization, where a lot of these manual jobs got replaced. You are coming to a position where a lot of these skill jobs too will get replaced, will get automated, and that's the reality of life. I mean, we have to face that reality. Now, in terms of how do you not get replaced is, I think broadly the advice I can give you is, regardless of which field whatever field that you are, I mean, whether you are from a management stream, you are in economic stream, commerce stream, any of these streams, AI is proliferating in every one of these domains, a faster and smarter way of doing things. So I would say, I think you should always stay ahead of the curve. You should stay ahead of what's happening in AI. Get into that so that if you look at all of the different roles that Ashwin was talking to you about, I think you should pick on some of those roles in your domain and add your specialized skills on top of that, where instead of trying to compete with the AI, you basically join the AI and how you can enrich the AI by a lot of these roles. And I think once you add a lot of your AI capabilities on top of that, that will be some kind of a safeguard against some these roles and you still having a job. But having said that, I think it's good to know in the post-COVID AI world that a lot of these jobs will get replaced, and that's the reality of life. So you'll have to make sure that you are skilled in AI, get into some of these roles where you kind of have a step up above others who are working in the same domain. Ashwin, I don't know whether you have any.
Yeah, no, I totally agree. And then as a mitigation strategy, what you should also be looking at is do some certifications. Like I don't know, Sujita, maybe your platform provides some. You have Bootstrap, so some things like that. So that's a very good way to actually upskill yourself. For MBA grads, I think there is a specific need around project management in AI. And Andrew Yang, who's an eminent researcher from Stanford and lead AI lead for Baidu and some of those top major companies, He says that project management in AI is actually a new developing emerging field, and he has written a lot of articles around it. So I think if you look hard enough, you will find resources. So online, you have a lot of these massive courses available for you. So constantly keep getting upskilled. That's the only way to avoid getting replaced by some of these AI systems. You must also understand what is AI replacing, right? The AI is replacing some of these mundane low-end jobs. It's not necessarily replacing the high-end stuff there, right? Some of the things that are repetitive in nature. For example, why would you pay a person to do that when it can be automatically automated? It's not come to the point where it's so intelligent enough to make decisions like a human would with his intellect. So if you are constantly upskilling yourself in some of these different areas around AI, and eventually take up things like internships and projects around it, build your profile. I think that would be a good way for you to get into the space if you not already have, right? So yeah.
Like one example, good example for the students is when Ashwin talked about some of these more manual things which can get automated. You can already see that. For example, Ashwin has worked in the area of virtual assistants. Now, slowly, what is going to happen is, if you are thinking, let's say, for whoever is planning a career in, for example, a call center, I think you certainly have reason to be worried, because in the future, as the virtual assistants get smarter, they get better. Organizations will start reducing their call center staff, and they will start depending more on technology. So AI will start taking more of that call center functions. So in the future, you will see this reduced call center, and in the next 10-15 years time, I see AI evolving to a point where companies will seriously consider, can I have an AI actually run the customer service?
Yeah, I think so.
Yeah,
I think well answered there. I think on both aspects, MBA, I think there are project management portions which are available. And rather than competing with AI, get on the bandwagon with AI and try to make it better.
And also I think one way to get that also into that for MBA students is, one interesting way to get into AI is, I think I have seen from my experience, a lot of these MBAs also doing business analysis, right, into business analysts in companies, and they typically go on to those sort of roles as well. And that may be a good way to get into that. Let's say you be a business analyst in the data science domain or in the analytical domain, would be a nice way for you to segue for you to get into AI. I think we are into the last question now. Sorry guys for whoever questions are not yet answered, but we'll definitely get back to all of you with answers. I promise you that. Now the last question, it's a bit futuristic in a way. Phil Bastian is asking us this question: where and how do you see the future of integration of AI and ML with the geospatial technology? What would be the next big thing going to happen in this integration?
I can take that, Suman.
Sure, go ahead. Okay.
So it's not the future; it's already there. Geospatial technology and AI. It's if you don't know, it's already there. One example is a lot of insurance companies actually, when you apply for a home, insurance for a home or something, right? At least here in the US, they automatically look at this geospatial data and figure out, hey, have you not disclosed certain details? For example, if your home has a swimming pool in the background, or it's quite close to risk-prone areas, they automatically diagnose and then say, hey, you get a higher insurance rate. It's automatically there. And in defense, a lot of these defense companies and government organizations, they're mining a lot of geospatial data, providing feedback to things like troop movement and things like that, planning. So it's being used there. Geospatial is also being used in transportation industry for planning and various other aspects. So yes, it's mainstream. Within the space of geospatial, there's also a field which is what we call things like navigation, right? So we have a lot of specialized companies that do provide navigation and telemetry. So if you're driving a car, you put on your GPS, your Google Maps and Waze and these kind of systems that actually relay the data to you, right? So you have real-time insights into where you're traveling, what you're doing. And this applies to, let's say, industrial setup also. So you have truck drivers and their telematics is being relayed. Where exactly on the map are they? And then you can do very intelligent things around it. You can plan your entire logistics around it. You can optimize your routes. So a lot of things can be done. So yes, these technologies are emerging and AI.
Let me give you to add to Ashwin's example. let me also give you an example from a military domain. See, in the military domain, there's huge applications for these kind of thing, and the sort of futuristic thing I can think of is, for example, let's talk about drones. Now, today, drones are starting to be, actively used in combat. Now, you saw the recent war where
in Jammu.
Yeah, you saw the recent attack in Jammu. Plus, I think there was a recent war with Azerbaijan and Armenia. The war was decisively swung due to drones that were enabled with AI, geospatial data, and they tilted the war in favor of. Now, think of it that in the future, as these military platforms get more and more unmanned, they get more autonomous, and applying AI to those drone swarms. Now, I can imagine a future war situation where you have the swarms of this autonomous drone control, which can perform reconnaissance operations, which can take offensive operations. All of these technologies will emerge in the future.
I think here we are talking about security and even further aspects of it. I think that makes us come to an end as far as this discussion is concerned. Suman Garu and Ashwin, thanks for your participation. There were very valuable inputs which were made. I think we had a very insightful discussion, ranging from how we took off to what is the future and the options available for students, both in India as well as outside. So it was definitely very insightful for me personally. I hope it was the same with all the audience here, and they were also very participative in asking a very, very diverse set of questions here. So very happy being part of this session at the end of it from my end. So thanks.
I must congratulate you, Sudhikar, for I wish these kind of platforms were there in our times. I think knowledge and information was not so freely available, but I think students these are blessed. You have such platforms that prepare them while they are in college, right?
Yeah.
In our times, we literally had to figure out career post the college. But this is very.
I think this technology and all enablement, maybe because of people like you working on the background right now, that we are bearing fruits of it. And I think, exciting phase for all of us, definitely. Right now, I think college students are in a much better position to take decisions and take care of their career options than even when I was in college. This was not the scenario, so I can emphasize with you, Ashwin Garu, on that. Thank you once again, and with this, I will hand over it to Tanvi to make the closing remarks and provide.
Thank you, Vijay. I and Ashwin, we enjoyed the discussion and I really enjoyed the interactions and great questions, and well done.
Thank you.
I would just like to thank all three of you for joining us and keeping the session very interactive, and very warm thank you to all the participants, especially all the people who have stayed 30 minutes beyond the stipulated time. We'll be sending across emails and all the answers. We'll add it in the email itself. I would also like to take a moment to thank all the training placement cells who collaborated with us to provide this opportunity in their colleges, and that is how we were able to reach a lot of students to visit us and ask questions simultaneously. A very warm thank you to CEI and Shri Bhaiji, I think he's here in the session, for helping us organize and connect with such industry stalwarts to actually provide the content that is valuable and that is not easily found in today's time also. So definitely a very warm thank you to everyone who joined today.
Thank you.
Thank you, Dhanik. Wish you all a very warm enjoy the evening on Saturday and maybe Sunday tomorrow as well.
Thank you.
And stay tuned for more such sessions. We'll be coming up with more valuable sessions. And you can mention in the feedback form also what else would you like to attend and see. Definitely. Yeah. Thank you so much, everyone.
Thanks again.
Thank you.